Welcome to the Cilium tutorial series. Cilium is an open source project that provides application-aware security. Today we will demonstrate Cilium's Kafka-aware policy. This demo will produce and consume with Kafka on Kubernetes applications, exhibit the danger of a compromised Kafka client, and finally, secure Kafka calls with Cilium. Star Wars is back to show how Cilium can enforce application-aware policies. This time, it's for Kafka. The rebels were able to obtain the Death Star plans from the evil Galactic Empire. How did they manage to do it? The Empire, having deployed Kafka as a messaging system, left itself exposed by having no Kafka API call isolation. Let's look at an example of the Empire's Kubernetes deployment with Kafka, and how the rebels were able to take advantage of the vulnerable deployment to obtain the Death Star plans. The Kafka broker is a pod running Kafka for the Empire's messaging service. It has the label App Kafka. Empire HQ is a pod representing the Empire's headquarters. It has the label App Empire-HQ. Empire Backup represents a backup to the Empire HQ. It has the label App Empire-Backup. These two outposts represent the thousands of outposts that exist in the galaxy. They have the label App Empire-Outpost. First, let's confirm all the Empire's pods and services are up. Here we do kubectl get pods and services, and we see all the pods in the Empire that we mentioned. Empire Backup, Empire Headquarters, a couple of outposts, and the Kafka broker. They're all running. Also to note is the Kafka service. It's running on TCP port 9092. The Empire uses Kafka as a messaging service. The Kafka broker is used to pass data streams between different applications. The Empire uses Kafka to produce and consume topics for various purposes. The Empire's Kafka cluster handles two topics in this example: Empire Announce and Death Star plans. Empire Announce is used to announce to all outposts all over the galaxy. Death Star plans is used to coordinate amongst those involved in creating the ultimate battle station. So when Empire HQ produces messages to the Empire Announce topic, it sends it to the Kafka broker, and from there, it is consumed by the outposts in the galaxy. Let's take a look at our Empire Kubernetes deployment. We are logged into the Empire HQ pod and have a simple script to produce a Kafka message to the Empire Announce topic. Similarly, we have Kafka consume scripts that are run on the outpost pods, which in turn consume the Empire Announce messages. So how did the rebels obtain the Death Star plans? By taking advantage of the Empire's Kafka vulnerabilities and compromising Outpost 9999, the rebels were able to use Kafka calls to consume the Death Star plans. Once the Empire HQ produced the new design to the Death Star plans topic, Outpost 9999 received the message. Let's see what this looks like on our example Kubernetes deployment. The Empire HQ pod produces the latest design to the Death Star plans topic, and the compromised Outpost 9999 is able to consume the Death Star plans topic, and thus retrieve the design plans due to no Kafka API security. The rebels took advantage of the legacy security implemented by the Empire, which opened up the Kafka API port 9092. Any client that has access to the Kafka broker could make any Kafka API call. The Empire learned from their mistake and implemented Cilium to prevent further Kafka vulnerabilities in their deployment. Cilium Network Policy allows you to specify the Kafka API calls and topics. In this example, Cilium specifies a policy for the Kafka broker, such that traffic coming from outposts should only consume topic Empire announce. Let's apply and take a look at the Cilium policy that enforces the Kafka API calls and topics on our Kubernetes deployment. First, the policy on which to apply the pod is indicated here under Endpoint Selector. Here, the Kafka broker is chosen to be protected by specifying the label App Kafka. Next, we see the ingress rules that whitelist which traffic can reach the Kafka pod. Looking at the ingress rules for label Empire Outpost, we see the rules defining the allowed set of actions. In this case, the API key fetch is the low-level API key that allows the client to consume messages from a certain topic. In this policy, we see that all the pods with the label Empire Outpost are only allowed to consume from the Empire Announce topic. Now that we've applied our Cilium network policy to only allow outposts to consume the Empire Announce topic, we confirm here that outpost 9999 is no longer able to produce to the Empire Announce topic. If it attempts to do so, an unauthorized error is returned. Similarly, if an outpost attempts to consume the Death Star topic or any other topic not specified in the policy, a not authorized error is returned. Cilium has the ability to configure policies based on identity label and Kafka API call. In today's example, we applied a Cilium network policy that enforced the isolation of Kafka API calls and topics for the Empire. With the Empire's Cilium Kafka-based policy, the rebels will need to find new strategies for next time. If you'd like to get started with Cilium for yourself, you can go to cilium.io/try. If you have any questions, you can join us on Slack and talk to many contributors and users of Cilium. Given that we're open source, you can check us out on GitHub. Thanks for watching.